In this video, we are going to be talking about Bronsted Lowry acids and bases and electron flow. So what are Bronsted Lowry acids and bases? Bronsted Lowry acids and bases are based on the transfer of a proton or an H+. So if you're looking at an acid-base reaction and you see that there is a proton that is being transferred from one compound to another, that is going to be a Bronsted Lowry reaction. Bronsted Lowry acids specifically are proton donors. So they are going to take their hydrogen and donate it to the base, and you can see the physical movement of that hydrogen from the acid to the base. Some good examples are HCl, H2SO4, HBr, and H2O. Bronsted Lowry bases are going to be the acceptors of the proton. So the acid is going to donate its proton, and the base is going to pick up that proton. Some good examples of those are sodium hydroxide and CH3O negative. Now we're going to talk about conjugate acids and bases. Conjugate acids and bases are always going to be the products of an acid-base reaction, so they're always going to be on the right side of the reaction. The reactant that is the original acid becomes the conjugate base when it is deprotonated, and the reactant acting as the base becomes the conjugate acid when it is protonated. So all that protonated and deprotonated means is the movement of a proton or an H+. So if something is being deprotonated, a proton or a hydrogen is being taken from that compound. And if it's being protonated, you're adding an H+ or a proton to that compound. So here we have an example of conjugate acid-base pairs. You can see here that we have hydrochloric acid as the acid and water as the base. Water can act as an acid or a base. It just depends on what you're reacting it with that determines whether it is the acid or a base. In this situation, hydrochloric acid is a strong acid, so relatively water is going to be more basic, which is why in this case it is acting as the base. So we're going to talk about electron flow in a few seconds, so just bear with me while I do this. But you see that water over here is becoming H3O. So what it's doing to become H3O is this lone pair right here is going to deprotonate the hydrochloric acid or take off this hydrogen. And so it's going to keep that hydrogen for itself, leaving just the chlorine behind. So we have the original acid, hydrochloric acid, and after that is deprotonated, it becomes the conjugate base over here. And so same thing for water, we have it as the original base, and after you add that proton to the water, it becomes H3O, which is very acidic. So another way you can think about it is if you were to reverse this entire equation and you're reacting H3O with chlorine, the H3O would be the proton donator and chlorine would be the proton acceptor. And so that's why this is going to be the conjugate acid and this is going to be the conjugate base. So now we're going to talk about electron flow. Electron flow is very, very important, and you are going to use it for the rest of your organic chemistry career. Once you start drawing out mechanisms, it's very important to understand how the electrons are acting and what they are acting upon. Basically, all a reaction is the movement of electrons. So it may look like this hydrogen is being added to the base, which it is, but that's not why the reaction happens. The reaction happens because the electrons of this base are coming and attacking it. And then the chlorine, because it's very electronegative, is going to take up the electrons that were binding the hydrogen and the chlorine together. So a big mistake that a lot of people make is that they draw this like the hydrogen going to the water, and that is not correct. You always draw the arrow from where the electrons are to where they're going to. So in this case, they're going from that oxygen and they're going and grabbing that proton. And then same thing here, the electrons between the hydrogen and the chlorine are going from that bond and they're being added directly to the chlorine. And so something else that's super important is the charges, because you know that charges are based off of electrons. And so if you have a reaction and you're moving electrons around, a lot of times the charges of the compounds are going to change. So you know from the periodic table that oxygen wants 6 electrons. That's where it's happiest. So you're looking at the formal charge, and over here it has 6. It has 1, 2, 3, 4, 5, 6 electrons. And that's why it's neutral and there's no charge on it. But after it adds that proton, it becomes positive. So it becomes positive because it's taking this lone pair and it's now using it to attach itself to this hydrogen. So if you look here, you now have 1, 2, 3, 4, 5 electrons in the valence shell. And so, as I said earlier, oxygen always wants 6 electrons, but it has 5 right now. And so because it is basically losing an electron, you have to add that positive charge. Same thing for chlorine. Chlorine wants 7 electrons. If you look at the acid, it has 2, 4, 6, 7 electrons. So it's happy and it's neutral. But once you take the electrons that are binding the hydrogen and the chlorine and you add it to the chlorine, you're adding 2 electrons to it. So now you have 2, 4, 6, 8 electrons. The new lone pair that it has is not shown here, but because it has that negative charge, it's implied that it has an extra electron than it normally has. So if it normally has 7 and it has a negative charge, you know it now has 8 electrons. So now we're just going to go through and do some examples and practice drawing the electron flow. This is super important to know how to do well, so the way I recommend studying for this and how to learn it is to just go to your book and do a bunch of practice problems. That's really the only way to get a feel for this. So this water is acting as the base, so the lone pair is going to come over here and it's going to grab that hydrogen, and the hydrogen is going to donate its electrons back to the fluorine. So over here we have H3O plus and we have fluorine with a negative charge, and that's because essentially the oxygen is losing an electron and the fluorine is gaining an electron. So same thing over here. You have water with a lone pair and it's going to grab the hydrogen. Hydrogen is going to donate its electrons back to that oxygen. And then same thing, H3O plus, OH negative. And again, lone pair grabbing the hydrogen. Hydrogen donates its electrons back to that nitrogen. So now you have H3O plus and H2 minus. And then again, you have that water grabbing hydrogen, donating its electrons back to that carbon. So now you have H3O plus and CH3 minus. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.